Welcome back. This is module 6 in our programming basics playlist. Up until now, we have focused on the building blocks of programming: data, variables, expressions, operators, and functions. In this video, we are stepping back to look at the bigger picture, the different overall styles or paradigms that programmers use to actually structure entire programs. This is a concept that will help you understand why different programming languages feel so different from each other. So, we will start by defining what a programming paradigm actually is, then walk through four major paradigms: procedural, object oriented, functional, and event driven programming. Before finishing with a direct comparison between procedural and object oriented approaches, since those two are the ones you will run into most often as a beginner. So let's start with the core question: what exactly is programming paradigm? A programming paradigm is a fundamental style or approach to writing and organizing code, a way of thinking about how a program should be structured. As you can see in this diagram, programming paradigms branch into several major categories: procedural, object oriented, functional, and event driven. We will walk through each of these individually in this video. And think of paradigms like different approaches to cooking the same dish. One chef follows a strict recipe step by step, another organizes by ingredient stations. Different approach, same result, a finished dish. Same idea with programming paradigms. Different approaches, but the goal is still a working program. So the paradigm most beginners actually learn first is procedural programming. Procedural programming organizes code as a sequence of steps and procedures, which is just another word for functions, executed one after another in order. So take a look at this flow. Main runs, which calls get input function, which leads into process, which leads into show output. It's a clear top to bottom sequence. So some things that you need to know about this style is that it focuses on procedures or functions that operate on data, following a clear top to bottom flow. It's simple and intuitive, making it a natural fit for smaller programs. And some classic examples of these procedural languages include C and early versions of Basic and Pascal. Then this is one of the most widely used paradigms today: object-oriented programming, often just called OOPS. Object-oriented programming organizes code around objects, bundles of related data and behavior, built from templates called classes. So look at the diagram. We have a class called car, which acts as a blueprint. From that single blueprint, we can create multiple objects. Here, car 1 with color red and car 2 with color blue. Same blueprint, different actual instances. So a class is a blueprint, an object is a real instance created from that blueprint. This approach groups data called attributes and behavior called methods together into one single unit. And some major language built around this paradigm include Java, C++, Python, and C#. Then this is a paradigm that thinks about programming quite differently: functional programming. Functional programming treats computation as the evaluation of functions built to avoid changing data or state outside of themselves. So here is an example of what's called a pure function, double of x, which simply returns x times 2 without touching any outside data at all. And notice double of 5 always returns 10 every single time, no matter what else is happening in the program. So functions behaves like math functions. The same input always produces the same output with no side effects. This approach avoids changing shared data, which makes programs easier to predict and test. So example of this style include Haskell as well as functional style code you will find in Python, JavaScript, and other multi-paradigm languages. And now the paradigm you have almost certainly interacted with already, even if you didn't know its name: event driven programming. Event driven programming structures a program's flow around events like clicks, key presses, or messages, each handled by its own function as it happens. Take a look at this flow. An event occurs, like a button click, that triggers an event handler, here on click, which then performs an action, in this case showing a message. So, what makes this paradigm unique? The program mostly waits and reacts only when a specific event actually occurs. This style is extremely common in graphical interfaces, mobile apps, and websites. And great examples include JavaScript running in web browsers and most GUI frameworks you will encounter. Then let's finish up by directly comparing the two paradigms you will encounter most often: procedural and object oriented programming. Procedural programming is organized around functions and procedures. Data and functions are usually kept separate. It follows a top to bottom flow. It's simpler for small linear programs, and a classic example is C. Object oriented programming, on the other hand, is organized around objects and classes. Data and behavior are bundled together. It models real world entities more naturally. It scales better for large, complex programs, and examples include Java, C++, and Python. And neither approach is universally better. Procedural code is often simple for small scripts, while object oriented code tends to scale more cleanly as programs go larger and more complex. So let's recap everything we covered in this module. A programming paradigm is a fundamental style or approach to organizing code. Procedural programming follows step-by-step procedures. Object-oriented programming organizes around objects and classes. Functional programming avoids changing outside data. Event-driven programming reacts to events as they happen. And different paradigms suit different problems, and many real languages actually blend several of these paradigms together. You don't have to pick just one. So that wraps up the module 6. In the next video, we are finally getting into control flow and conditionals, where we will learn how programs actually make decisions using if and else statements. If this video helped the bigger picture of programming styles click for you, drop a like, and I will see you in the next one. Thank you.